All right, Stats, I'm here to introduce you to your final exam project. So again, this is supposed to kind of connect to what's going on with the coronavirus a little bit, but again, it's just an example. This was released back in March, right when coronavirus hit. So again, it could be a little bit out of date, but still, uh, it's a good problem to look at. Okay, so there's kind of an overview here. Again, the project overview says chances of getting the flu. So you can read this on your own. I'm going to look at the example with you. So it says, consider the following simple example of an infectious disease, like a cold or flu, and spread throughout a small apartment building. Okay, so again, we're taking a huge problem, making it small. Suppose that a strain of the flu has a 1-day infection period. For example, a person with the flu can only infect another person for 1 day, and after that, the person can't spread the flu and is immune. That is, once you get the flu, you can't get the strain of flu again. Okay. The strain of flu is very potent. If a person comes in contact with someone with the flu, the person will get the flu. So you have 6 people or tenants living in a small apartment building. One person catches this strain of flu and randomly encounters one of the other tenants during the infection period. And this second tenant gets the strain of flu. The second tenant affected by the flu visits a third tenant at random during the next day. And this third tenant gets the flu. This process continues with a newly infected person randomly visiting someone who hasn't had the flu or visits an immune person, and then the strain of flu would die out. If an infected person visits an immune person, then the spread of the flu will end, as the flu in this example is only a 1-day infection period. How likely would it be for all 6 people living in a small apartment building to catch this strain of the flu? Okay, so again, 6 people, each person can infect one person the next day. How likely is it that you would get all 6 people to be infected? Okay. So task 1, this is going to go through the statistical process, right? Ask a question. You have to formulate a valid statistical question. And it says, think about what would be the highest number of tenants who could catch this strain of the flu. So again, in this statement, you're kind of just restating the question that's already been posed. So you should be able to find it in the words. Please just use the word probability. Geez, I can't spell. Okay, so when you formulate this question, use the word probability in your question. So you sound like a statistician. Okay. All right. Task 2, collecting the data. So it says, in order to simulate the flu, the spread of flu, use a 6-sided die and assign each tenant a distinct number 1 through 6. So we're going to see this example below. So say day 1, you roll the die and get a 3. That means that tenant 3 is the first person to get the flu. Roll the die again, you get a 4. This means that tenant 3 has now visited tenant 4, and tenant 4 now has the flu. Okay? So now 2 people have the flu. All right. Now, if you were to roll a 3, tenant 3 cannot visit him or herself, so you would roll again. Okay? So again, if whatever person just got the flu, they can't get it again. All right? So now on day 2, you roll the die and get a 6. So that means that tenant 4 has now infected tenant number 6. Okay? So now 3, 4, and 6 have the flu. Okay? Tenant 3 is immune now. Okay? Tenant 3 is immune. So now, if tenant 4 had rolled a 4, we'd roll again because tenant 4 can't visit him or herself. So now on the third day, tenant 6 rolls the die and gets a 3. So now tenant 6 is going to visit tenant 3, but tenant 3 already had the flu. They're immune, so it dies. So the only people in this example that got the flu are tenant 3, tenant 4, and tenant 6. 3 people of the 6 got the flu. Now down here, this is sort of the situation, right? You have 1 through 6 people. So tenant 3 had it first, passed it to 4, 4 passed it to 6, 6 went back to 3, and it died. All right. Now again, the one thing is, if you roll the same number in a row, you have to roll again, because again, tenant 3 or person 3 cannot infect person 3. They're the same person. So now you're going to go through and do some examples. So I have an example for you of how to fill out this table. This goes with the example above. So 3 infected 4, 4 infected 6, 6 went to visit 3, but they're already immune and it died off. So 3, 4, and 6 got the flu. That's 3 tenants infected. So I'm going to do an example with you here so you can see at random.org. So if I click here, I should go to random.org. So we're going to roll 1 die at a time. So we're going to roll the dice. Okay, so that means that the first person to get the flu in my example is person 2. I'm going to roll the die again. Person 2 infected person 1. So now we have 2 and 1 infected. I'm going to roll the die again. Okay, so now person 2 infected person 1, and person 1 infected person 6. So now we have 3 people with the flu. I'm going to roll the die again. Oh, number 3. So now 2 infected 1, who infected 6, who infected 3. Now we're going to roll the die again. And now we're back to 6. So 2 infected 1, infected 6, infected 3, but now 3 visited 6 again, and it dies. Right? Because now 6 is immune. They've already had it. So 1, 2, 3, 4. In this case, 4 tenants out of the 6 got the flu. So on your table, you would do 2, 1, 6, 3, 6. And that means that 4 people got the flu. Now again, say for example, on this last roll, right? On this last roll, 3 would have rolled it and they would have gotten a 3 again. Then you just don't count that and you roll again. Okay? If you want to include it in your list, so now it was 2, 1, 6, 3, 3, and then say he rolled the 6, you could write that down. But again, I would just, if it's a double, don't write it. Don't write it. Just skip it. Okay? So I wish my example would have included that, but it didn't. All right? So again, if the person rolls their own number, you have to re-roll because that person cannot infect themselves. I hope that makes sense. If it doesn't, ask a question. So you need to perform that, it looks like 10 times, right? Okay. So there you go. So that's you gathering the data, right? Okay, awesome. So now, we have done an 82 simulation ahead of time. Here is the frequency table. So how many times 2, 3, 4, 5, or 6 tenants were infected? Here is your breakdown. Your job is to find the relative frequency or the probability. We're going to round these numbers to 3 decimals. Okay, if you don't remember how to find a relative frequency or a simple probability, you should look at section 1, 2, right? Or maybe, I think it's 1, 2, yeah. Could be 1, 1 even as well. That's way back when. Okay, next. Okay, so now you need to create a dot plot using the results of these 82 numbers. So if I go to the dot plot, right? I have all the links for you, I think. So make sure you go back here, you type in the number of tenants infected, right, as the variable name. Okay, and now you have to enter 82 numbers. So there are 17 twos. So watch what I'm going to do when I go to this. I typed in the name, right? I have to type in 17 twos. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 17. It's not difficult, just is annoying, right? Because the next one is 33 threes. But you need to make sure that when you click begin analysis, that this n is 82. And make sure you're not having any like goofball numbers, right? It should be 2, 3, 4, 5, and 6 on your axis. You need to somehow copy and paste that here, right down here. And that is organizing your data, displaying your data. Okay, so that's all part of task 3. Okay, now task 4 is interpreting your results. So again, it says based on the results of the simulation, should we be surprised if we found out that all 6 tenants in the small New York City apartment building were infected with the flu? So that's where you're going to look at your dot plot and you're going to analyze some of the dots, right? And again, should we be surprised? This is the same thing as convincing evidence. There should be a certain percentage that is going through your brain right now that you should be comparing your data to. And then last but not least, a little extension. So that was a simulation. So that's all experimental probability. You can actually do this theoretically. So again, the simulation gave an estimate. You can use formal probability rules to find the exact probability. So down here, let X be the number of people infected. So I'm going to do an example for you. Let's say that 4 people got infected. So how did I get this probability? I'm going to redo it over here. So find the probability that X is 4. Okay. So first off, the first person, right? You have 6 people out of 6 people that could be the first person. So this is the first person infected times. Now, once the first person infected, there's now only 5 people that person can visit, but it could be any one of the 5. So this is going to be the second person times. Now, so now 2 people have it. The third person, well, now the third person can only can visit 5 other people. So this second person can visit 5 other people without it dying off, or 5 people. But of those 5 people, he can only visit 4 and the virus continue, because he can't visit himself, which is why this number is not 6, it's 5, and he can't visit person 1. He can't visit this person again. So that's why it's only 4. This would be the third person. Okay, so now that person can visit 5 people. They can't visit themselves. That's why it's 5. They can't visit the second person. They can't visit the first person. So that means of the 5 people left, there's only 3 that they can visit and infect. And that would be the fourth person infected. And now you have your 4 people infected. So now this person can visit 5, but now for it to die, they have to visit one of these 3 previous people, the third, the second, or the first. And that's why this is 3. Okay? And you would just multiply across the tops. You would multiply across the bottoms. And then when you get those numbers, you would divide, right? And that's how you get your decimal. 0.288. If you have questions on this part, ask me. It is an extension part. It might be a little difficult. But again, if you follow this format, you should be able to do well. And again, you'll see a pattern. So start with 2, work your way to 3, and so on. Okay. And again, if you do it correctly, when you add up the probabilities, you should get some nice number that I think, or very close to that nice number, depending on rounding. And that's your project, right? So again, there's 5 tasks. The first task really doesn't count because it's just restating the question. So you really have only 4 things to do, right? 4 things. So today is Thursday, so you have until next Wednesday. So you have plenty of time to get this done. And again, I will not let it hurt you. I will only let it help you. All right, ask questions if you have them. Good luck.